Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you find my videos interesting and important to your studies, also please don't forget to subscribe. That's one way you can help me refresh, energize, and inspired by doing or by making many videos. That would be very helpful, beneficial to your studies. So I'll call this static statrigometry because the problems created here and the lecture videos are important as basic information, basic ideas before you completely study trigonometry and statics. I hope that these videos will help you improve as an engineering student and hopefully excel, if not top, in your respective engineering careers. So here we go. The topic is about angle measurement. So let's familiar with angles and measurements. So towards the positive x-axis, because angle is measured positively, remember angles are measured positively in counterclockwise direction. So this is 0 and that 0 may be 0 degree, 0 radian, 0 gradients or grades or just grads, 0 grads, or mil, MIL, which is milliradian, but I will not discuss it here. 1 milliradian is 180 over pi all over 1000. So that's 1 milliradian, 0.05729. I think that's the equivalent. So in counterclockwise direction, so next is 90 degrees. So that's 90 degrees, which is equal to pi over 2 radians. By the way, if it is radians, you may put the units, you may not. If there's no unit displayed besides the value, it means that it is in radians. Then it is equal to 100 radians or grads, meaning the whole revolution, one full circle or one complete revolution is equal to 400 grads, 2 pi radians, 360 degrees. So that would be the conversion later. Then from positive x-axis to that position, that straight line angle, 180 degrees, which is equal to pi radians, 200 grads. Then 0 to this, that's equal to 270 degrees, 3 halves pi radians, 300 grads. Then for one complete revolution, that's one complete revolution, we have 360 degrees, 2 pi radians, 400 grads. Therefore, the conversion is uh, one revolution is equal to 360 degrees, 2 pi radians, 400 radians or 400 grads. By the way, the other term for grads is metric degree in the attempt of making it a centesimal unit per 100 per quadrant. So that's the attempt. So the other term for grad is metric degree. Metric degree. So here is the first problem. Convert 60 degrees, part A 60 degrees, B 150 degrees, C 217.5 degrees, and D 312.6 degrees to revolution, radians, and grads, or revolutions, radians, and grads. So 60 degrees, for converting it to revolutions, we multiply it by one revolution per 360 degrees. That's the conversion factor. So therefore, it is equal to be exact, 1/6 of a revolution Or if we express this in decimal, 0.1667 to 4 significant figures, 0.1667 revolution of a revolution. Then this is equal to 60 degrees times 2 radians, 2 pi over, or 1 revolution per 2 pi radians, or 2 pi radians per 360 degrees. Sorry. And that therefore it is equal to pi over 3 radians, or you may not put the decimal. Pi over 3 is 1.047 of radian. Then it is equal to 60 degrees times 400 grads over 360 degrees. That's the conversion factor. 400 grads equals 360 degrees. So expressing as a fraction, to be accurate, it is 200 over 3 grads. 200 over 3 grads. And in decimal, it is equal to 66.67 grads. 1B, 150 degrees. So 150 degrees times 1 revolution per 360 degrees is equal to, in fraction, it is 5 over 12 revolution. In decimal, 0.4167 of a revolution. Then it is equal to 150 degrees times 2 pi over 360 degrees. If you want to convert that to radians, that's 5 pi over 6 radians. Or in decimal, that's 2.618 radians, understood radians. 150 degrees times 400 grads over 360 degrees. In fraction, that's 500 over 3 grads. In decimal, 166.7 grads. So of course, this is calculator aided. But these exact values in fractions can be solved or can be computed without the calculator. 1C, we have 217.5 degrees, so 217.5 degrees times 1 revolution over 360 degrees. And in fraction, that would be equal to 29 over 48 to be exact of a revolution. In decimal, 0.6042 of a revolution to 4 significant figures. Then equals 217.5 degrees times quantity 2 pi over 360 degrees. In radians, 29 pi over 24 radians. In decimal, that's 3.796 radians. So equals 217.5 degrees times 400 grads over 360 degrees. So it is equal to 725 over 3 grads. And in decimal, it is equal to 241.7 grads. And finally, 1D, we have 312.6 degrees. So equals 312.6 degrees times 1 revolution 360 degrees. So in fraction, it is equal to 521 over 600 of a revolution. Then in decimal, that's 0.8683 revolution. Then equals 312.6 degrees times 2 pi over 360 degrees. In fraction, 521 over 300 pi, or 521 pi over 300 radians. 521 over 300 pi, or 521 pi over 300 radians. In decimal, 5.456 radians. Then equals 312.6 degrees times 400 grads over 360 degrees. 312.6. Using the calculator, it is 1042 over 3 grads. In decimal, it is 347.3 grads. So that's it for this video. I hope that you enjoyed watching. Although this is a very simple matter for those who are engineering graduates, but for high school, senior high school, junior high school, who want to pursue engineering in the future, this topic is very important as a good background in engineering.